Welcome to our Quantum Deep Dive. Today, we're exploring the really groundbreaking work of Lieven Vandersypen. You can almost call him an architect, someone who truly built foundations for quantum-based chips. And we're drawing our insights from a really illuminating essay on his journey by Jorgo Schneppet. When I was reading Schneppet's piece, what really jumped out was how Vandersypen isn't, just a brilliant physicist. He's someone who fundamentally shifted quantum physics from theory, from the abstract, into actual, tangible, powerful technology, like you said, a bridge builder for the quantum age.
That's exactly it. In his whole career path, it really shows that transition perfectly. It's not just about isolated discoveries. It's more about synthesis, about the engineering challenge, and literally creating the infrastructure we need for a quantum future. His early work, it wasn't just adding knowledge, it laid the strategic groundwork. It really set the direction for so much that came after.
Right. And maybe the first time his name really hit the headlines in the quantum world was during his PhD at MIT, working with Isaac Chuang. Back in 2001, they pulled off something pretty monumental, the first experimental demo of Shor's algorithm. That super complex quantum factoring algorithm.
Using NMR.
Yeah, nuclear magnetic resonance.
Yeah.
And what's so fascinating about that 2001 experiment, it isn't just that they did it, but what it meant. Because, NMR itself, using atomic nuclei as qubits, that was never really going to scale up to a useful quantum computer.
Right. Imagine trying to build a chip with atomic nuclei. Not exactly practical.
Exactly. But it wasn't about the hardware then. It was the proof, unequivocal proof that you could systematically control quantum information and use it to solve a real hard math problem. It took quantum computation off the blackboard and into the lab. That changed everything, really, about what people thought was possible. Okay, so NMR proved the concept. But for practical quantum computing, you need scalability. That's the big hurdle. So after MIT, he goes back to TU Delft. How did he tackle that massive jump from, single atoms to something you could actually manufacture?
That's where his real engineering insight shines. That strategic shift, moving to control individual electron spins inside semiconductor quantum dots. That was the key.
Quantum dots. Okay, that sounds much more chip-like.
Precisely. Think of it like moving from building with these, awkward individual atoms to engineering tiny, precise components right onto silicon. His team meticulously worked out how to make high-fidelity 1 and 2 qubit gates work, integrating them into these semiconductor structures. They were literally designing how quantum logic gets miniaturized. They even worked with Intel on CMOS-compatible platforms.
Yeah, CMOS-compatible. That's huge for actually making these things in existing factories, right?
Absolutely. A massive step towards manufacturability.
And his vision went beyond just the tech itself, didn't it? He was building the whole environment around it. Founding and leading Quatech in the Netherlands, it seems like a really strategic move, bringing academia, engineering, industry all together.
Oh, definitely. Quatech became a kind of template, really, for national quantum efforts everywhere. It wasn't just another research center. It was this integrated engine showing that to speed up progress, you couldn't just stay in academic silos.
And that led to things like Quantum Inspire.
Exactly. Europe's first public cloud quantum computing platform. And that wasn't just a cool gadget. It directly answers that critical question of access and impact. Vandersypen always stressed that quantum computing shouldn't be locked away in labs.
Right, making it accessible.
Yeah, making the hardware available, training the next generation, pushing for standards through things like the EU Quantum Flagship, which is this huge European effort to get quantum tech from research into the real world. And he always emphasized the need for ethical thinking and responsible development from day one.
What an incredible journey to trace. Lieven Vandersypen's work really does map out that whole transition, doesn't it? From deep quantum physics to functional, scalable, and importantly, responsibly developed tech. He's not just a researcher. He really has been an architect of this entire era.
Absolutely. His legacy is connecting all those crucial dots, the deep science, the technological foresight, and that sense of societal responsibility. He didn't just invent things, he built a whole culture around making quantum progress open and truly impactful.
It's been really fascinating digging into Lieven Vandersypen's profound contributions, all laid out so clearly in Jorgo Schneppet's insightful essay. You can learn more about his pioneering work and other great science writing over at schneppet.de. Thanks for joining us on this deep dive, and we'll catch you next time.